Quantum computing is how you compute if you use the way that things are working on a subatomic level. So you can handle existing problems much faster, but you can also handle problems that currently are not really able to be handled, simply because the amount of input is too vast for us to calculate it. So for instance, if you have something like photosynthesis, why is it possible to get energy from the sun? That is something any tree, any leaf can do, and we don't really know how it works. We think we know, but we only understand what's the input and output. When you come to the molecular level, you can't calculate how it works. That's something you can do with a quantum computer, and maybe we can then take that attribute and put it, in a piece of clothing or something. The group I'm leading is a group that is called Newtech, and it's not for nothing. It's because we constantly are looking for the next wave. And what we realized was that it was now possible to do what is called quantum key distribution, which is a way to ensure that when you have a message between two parties, that you can do that message without a possibility of hacking. So it's a hack-free opportunity where you can't break it unless you break the law of nature, which is something you don't. It also goes for logistics. So already now you can simulate a kind of a quantum computer. And this means that currently, for instance, we are running a project for a large telco where we can see that all these service cars that are driving, we can take out a lot of the time that they take to go from A to B by using quantum computing to calculate the right route. It's very complicated. I mean, you would think that it's just the Google Maps, but that's just going from A to B. But if you have something like real logistics, like DSV or Maersk Logistics or whoever, they need to do a lot of different things, and they can't just say we're going from A to B. They have to put in, yes, I can be here at this point, but I should also be there at that point. This is closed at this point. This is impossible at this time. All these parameters, and I can't carry more than this load. And I mean, you can imagine how difficult it is. They have whole departments trying to do it. I think the first most important is to sort of make sure that more knowledge is out there. So for instance, the fact that we can simulate parts of what a quantum computer can do already now is very important. It's also important to know that there's actually already a quantum computer. There's some quantum computers out there that we can begin to use. That's also extremely important, because I think in a lot of ways most people are thinking, yeah, that's fine, this is 15 years from now, I've watched a movie, but they think it's in the future. But there's something right now that can be exploited. I think that's a key thing to talk about.